What if I told you the hardest problem in robotics right now is the hand? We've taught robots to walk, even to kick a ball at the World Cup. What is not solved for is picking up a wet glass or sorting grapes without crushing them, and that's exactly what 1X Neo's new hands are built for. The reason this is an engineering nightmare is that most robots are physically numb. To get enough strength into a small joint, engineers use massive gear ratios, usually 100 to 200 to 1. That means the motor might have to spin 200 times to move the joint once. These joints become right-only devices. At this point, you command a position, the finger goes there, but when it hits a countertop, the motor never feels the impact. The industry workaround is to point cameras at the hands and try to guess contact from video, which is like trying to tie your shoes while watching a delayed video feed of your own hands. 1X solves this with force transparency. By moving the motors to the forearm and using a tendon-driven system, they drop the gear ratio down to about 5:1 to 15:1. Now the joints are read and write, they can act on the world and feel it. Because every joint behaves like a closed-loop sensor, Neo gains proprioception. It knows its hand shape and the load it's carrying without having to look at it. Magic number here is 25. Neo has 25 degrees of freedom, 22 in the fingers and palm, plus 3 at the wrist, all biased towards a truly opposable thumb to mimic human anatomy. Delivers about 17.75 nanometers of wrist torque and 45 of distal flexion force, enough to lift a 20-pound kettleball, and about a 0.2 millimeter accuracy. It can still pick up a single screw off the floor. And because it's IP68 waterproof and food safe, it can scrub dishes in hot, soapy water and then literally wash its own hands in the sink. Taken together, this builds a perception stack in the hand itself. So you start with a rigid gripper, blind and numb, add force transparency for a controllable force range, add 25 joints for fine motion and shaping, tactile skin that feels shear and slip, and then add reflexes. So if a wet glass starts to slide, the hand feels it and tightens its grip before it hits the floor. 1X is positioning the hands as the API to the physical world. A standard gripper gives a developer maybe 3 verbs: pick, place, and push. Neo's 25 joints unlock a much richer vocabulary, whether it's assembling Legos, zipping, grabbing Funyuns, playing video games, and many more. This becomes 1X's hardware mode. By manufacturing the motors, tendons, and shear-sensitive skin in-house, they're building a vertical stack that rivals cannot just buy off a shelf. Target is about 10,000 units in 2026 at roughly $20,000 each. But here's the catch: the hardware is ready, the autonomy isn't. Many complex chores still rely on expert mode. A remote human guides the robot. That creates a powerful data flywheel. Every teleoperated task becomes training data, but also a trust gap. Would you be comfortable with a stranger remotely steering a camera-equipped machine through your home?